Hello, Spark fans, and welcome back to Advancing Spark. So this week we're going to dive into something called Z ordering, or Z ordering, depending on which side of the Atlantic you're from. And this is all about how do we actually make the data in our files more efficient. And it's kind of a hard concept. So when I first came across Delta, and it's all to do with Delta Lake, the whole idea of Z ordering was like, what? Do I need to do that thing? Does it make any sense? So we're going to run through it, how it works, what it is, why you should use it, and the impact it's going to have when you turn it on. If you like the video, don't forget to like and subscribe, and let's dive in. Okay, right, so super quick. I've got a load of little files. So I've got 4 little small files, some data, some A's, some integers, and then all importantly, I've got that name column. So I've got Bob and Fred, and Andy and Tom, Brad and Tim, blah, blah, blah. Now, Delta, super smart. If I write a query saying select account star where a name equals Brad, it does a thing called data skipping if it understands how your data is organized. So data skipping, if we had it turned on and using this data, it would look at this and it uses a min-max value in the Delta transaction log. So it can go to the translog and say, does this file contain the data I need? Well, it's got data from Bob to Fred, and Brad sits alphabetically in the middle of there. And then Andy to Tom, and again, Brad's in the middle. Brad to Tim, Brad's obviously in there, and then Dan to Jan, Brad's not in there because D becomes after B. So if we had data skipping working on these files, it would actually see a lot of that data. And Z ordering, it was all about changing the ordering of the data so that you're more efficient when you're doing data skipping. And it's built into the optimize command. So the optimize command itself, you can run it without Z ordering, and that just says, here's a load of files, let's just compact them down. So it's saying I did have 200 files. Actually, they'll be more efficiently compressed, more efficiently held, have less overhead of going back and forth and opening files on the disk if I hold it as 10 files. So it's doing that kind of thing. So that's not great. It's not going to do data skipping that well. It might just by chance go, oh, that one doesn't have any data, but there's no rhyme or reason to it. So if we put if we put Z ordering on words, so we said, take this, Z order it by the employee name. And again, I need to do that at the same time I'm running an optimize command. And then it's gonna combine some of these files. So I'm gonna have bin compaction. And I end up with 2 files in this case. But you can see the ordering of which records is decided to put in each of those files is based on the column I Z ordered by. So I've now got Andy to Dan in one file, and then Fred to Tom in another file. And so when I run my query, it goes, well, I don't need to look in the second file because I'm looking for Brad. It's definitely going to be in that first lot, not going to be in the second one. So obviously, the column that you Z order by really impacts how well you're going to find your data. Because the middle column, that kind of 1s and 2s, actually both files have got minimum 1, maximum 2, minimum 1, maximum 2. So I could have Z ordered by that instead, and then it'd be more efficient when I'm running queries that need to look at that column. But then my Andy's, Bob's, Fred's would be all over the place. So there's a bit of a balance. It's what column do you want to Z order by? How are you trying to optimize your data? And this is a lot, if you're from the SQL Server background, like a clustered index. Essentially, you're saying, I want to store my data on disk according to someone with a specific search predicate to make it go faster. That's kind of what Z ordering is doing. So you're giving it a logical dimension. You're saying, use this attribute. It's going to change how it puts data down onto disk, optimizing it so hopefully it'll spot that you're filtering on a specific column and then go, cool, don't need to query the rest of it. That's what Z ordering is. That's what we are trying to get working. Okay, so there is a whole blog post about it on the Databricks site talking about what Z ordering does, how it works, that whole bin packing compaction stuff. Talks about data skipping. Most importantly, it's got a few notebooks. So you can go and dive into the Python notebook to get an idea of how these optimizations work. So obviously I just dove into that, I pulled it out, I've imported it into my local Databricks cluster. But I was going through it and it's useful. It kind of explains how things work. So we're pulling out some flights data. Again, this is using, whenever you're using Databricks, don't forget, you will always have Databricks datasets as a mount point. So you can get all of the demo code, you can just go to that and pull it down, it's super easy. So it's pulling that in as a data frame. The original one, it does a load of stuff, just writing that down as Parquet. And then it doesn't optimize and Z order and shows you the query performance before and after. And that's, for me, well, one, it's comparing Parquet to Delta, and two, it's comparing pre-optimize to post-optimize. It doesn't really tell you what Z order does in that scenario. So I ran through it, I followed it through, I changed it so it's just writing it straight down to delta. It does a query before optimizing, and you can see it took, 31 seconds. We can have a look at this view and say, well, actually, no, not that one. We can say, what did that actually do? So inside there, what did you go and do? It read 2,297 files. There's a lot of work involved, lots of going and opening lots of small files. Did the optimize. So again, we're optimizing, it's Z ordering by the day of the week. And optimize is great because it gives you that little, this is what I've done. So it removed 2,308 files, it added 300 files. So it took 2,000 odd files and then combined them into much chunkier files. So it's now got 300. And you can see it's got a Z order stat. So it's gone, it's created that. We have a cube. And essentially that Z order cube is what it uses to reference going, what's it Z ordered by? Oh, you've got that as your Z ordering strategy. Kind of like your clustered index key. Going off and saying, right, I can use that doing data skipping. But then the example query that we've got is actually just saying, well, go through, filter it by a certain thing, go run it, pull it back. And this actually isn't hitting, it's not doing data skipping. So if we go and have a look at what happened in this query, we can see, well, it read all the files. So it read the 300 files. And for each of the bits of data to actually sort of pull that back more efficiently, great, but that's not actually doing Z ordering. It's doing Z ordering, it's not doing data skipping. So I thought, you know what, I'm going to make my own quick version of this. I'm going to kind of quickly run through, and we can have a look a little bit more in detail what's actually happening here. So again, back to Databricks datasets, got NYC taxi, so pulling that down. I'm doing a little bit of globbing just to say, you know what, I want the 2009 data, but just don't try and read it all in and filter down because this isn't partitioned. Let's just give me the ones that have 2009 in the title, and then give me all files. All files that pertain to 2019 is the plan. I'm using infer schema out of laziness, so I'm doing a quick read of a sample file and then applying that schema into the main one, otherwise it takes ages to read them all. So I end up with this taxi data frame, which is just all of that data set, which is 2019. Okay, so I'm pulling it in. I'm doing a bit of fiddling to add some partition columns, because what I want is for this to just give me that pickup date, year, month, and day, because that's what I normally used to do partitioning on. So year is my year, month is year, month, day is year, month, day. And that means you can do range queries on partition columns, which makes your life a hell of a lot easier. So I've got that in there. So we can have a look at that data. So you can see I've got my new columns over on the edge. So I can just see what I'm going to partition by, which makes my life super easy. I'm going to write it down. I'm doing a quick filter. For some reason, these files have pickup dates all over the place. So I'm just making sure just give me 2019 data. And then I'm doing this cheeky little fellow. I'm saying, why don't you repartition to 200? Now that normally 200 is the bad number that your shuffling does, but I'm forcing it to do a little bit of inefficiency here because I want to test this out. So I'm saying, take my data frame, and I probably read it, I think it reads it in as 12 different blocks because of 12 different month files. And I'm saying, take them, do a shuffle, force a shuffle into 200 blocks. I'm going to have data all over the place. So I wouldn't normally do that. I'm doing that so we can have a look at how it works. Then I'm writing it down with a partition into a delta table. So that's not going to be ordered. I'm not doing a Z order, I'm doing optimize. I don't have auto optimize turned on. This is just shoving this data straight down onto disk. Okay, and we can see in here, a couple of stages. So I had my 12 stages, reading my 12 individual files, and then my 200 tasks in second stage, which is when I've told it, force it, go off and do 200. So when it writes that down, I'm going to have 200 different files. So we can go and have a look at what that looks like. So over in our lake, I've got my transaction log. So I've already ran this, and annoyingly optimize takes a little while to run. So I've ran it in advance. But we can say for that first JSON file, what actually happened in there, download it, open it up locally. Okay, so I get a ton of stuff. So each file that was added in this original insert, I've got inside my transaction log for my delta table, which is good. So I can see it's all 2019. And you can go and have a look. So what it does, it gathers stats on each of these files. So I've got this stats column. I can see how many rows are in there and minimum values. So I've got my trip pickup time, and I can see 2019 0101 across all of these files. So it's not grouped it into months. It's actually just jumbled all of my data together. They've all got data from the first day. If I scroll over, we'll find Max. A bit further. Okay, so into my max values. And going across here, so I can see again, 2020 I want a 1. Basically, right at the end now of my thing. So all of my 200 files, I've got data from all the entire range of that year. So if I try and say, somewhere in this year, give me that day, it's going to have to read every single file. So based on the min-max, everything has all the data just all jumbled up. That's no good. Okay, so that's our starting point. So let's go back. What do we do next? So I quickly pulled it into a Hive table. And actually, the optimize works either on Hive or directly on Path. But just wanted to try some stuff. So I can do a select distinct and go get some data. And then I can run an optimize. So I can say, go and optimize this and Z order by the pickup date. So it did a similar thing to the last one that we saw. It removed 200 files. So it saw my 200 that it created, went, oh, okay, they're all garbage. And it managed to compact them into 10. Now, there is a minimum size that your optimize command is going to aim for. So I could have changed that. I could say, actually, make it each file smaller, each file bigger, and you can tweak it. Normally, optimize aims for about a gig. So it tries to make each file roughly a gig, roughly even number of rows. It tries to avoid data skew and get stuff in there. So see what it's done, what it's gone in. And actually, so total size hasn't really changed. So changing this round, I've actually not gained much efficiency by having these larger files. Because the taxi data set, it's nearly all integers, there isn't really that much I can get from repeated rows and all that kind of stuff. If there's lots of strings, lots of repeated dimension values, that would compress a hell of a lot better. In this case, it's all about how I've organized it to optimize for data skipping. I can see my Z order stats. So again, I've got my minimum cube size. And so it's gone in and it's rearranged my data. So it's changed that physically. Okay, so we can go back and have a look, but let's have a look at what it actually did in the transaction log first. Let's get this open. Okay, so firstly, I've got removes. So it's like, I'm getting rid of all that junk, all those 200 files. And again, remember, it doesn't physically remove them, it logically removes them in the transaction log. It's only going to physically remove them when you run a vacuum command. And then I've got my 10 new files. So these are my nice optimized ones that have been reordered. So I can go in and see the number of records. Oops. And I can see over here. So actually what it's done, I've got my trip pickup date, and half of them is starting at 0101, and half of them are starting at 621. So essentially what it's done is it said, okay, the most logical way to pack these in is to create just 2 options. And then so I've got 5 files in one option, 5 files in another option. Anything in the first half of the year is here, anything in the latter half of the year is here. That's I believe that's to do with the minimum cube size, which has gone, okay, it only makes sense to do 2 cubes given the amount of data that we've got. And the more cubes that you have, obviously the more granular that split would be. I could force the values to be 12, making sure it's actually got 12 individual cubes, each of which is a file. But in this case, it's looked at the amounts and said, you know what, you're fine having just 2 groups. Kind of on a B tree, really. It said, start of the year, end of the year, pick your collection of files. And if we go over, we can have a look at the maximum dates in here. So you can see, there we go. So right at the end, we've got the first chunk, which started on the 1st of Jan, are now going through to the 21st of the 6th. And the latter, which started on 21st of the 6th, are going through to the end of the year. So it's organized the data that sits in these files. It's not just done the compaction into those 10 files. It's done logical ordering of data to enable data skipping. Okay, so that's what's happened inside my data. And again, you see that through the transaction log. And it needs the transaction log in order for Databricks to know what to use. In order to know that these files are organized in that way, that's essentially the index being kept there so it knows what to do. So if I go and run some things, so we just run that whole thing, we can say, what's going on here? And we should see that just querying all this data. Okay, yeah, so it read all 10 files. Just makes sense. So there are 10 files now. It's ignored the original 200. They're now obsolete. But it had to read everything because I'm not filtering. I'm just saying bring back everything. Now, actually, in terms of getting those counts, it's going to be a little bit more efficient anyway because each file is going to have fewer, the cardinality of those values is going to be less because each file only contains a subset of those data, which is great. But then if I try and do something where I'm filtering it, so I'm saying I want to do a count from my Hive table, I'm including the partition filter just to remove that as a point of complexity, and I'm saying, okay, I want to filter on my Z-ordered column where it equals that date. Now we know that 09, that's in the latter half of the year, so there's only 5 files that contain data pertaining to that month. So we look at our Spark jobs, go over here, we can have a look in my associated query to get the details, and I've got 5 files read. So it's automatically done data skipping, and that's not a configuration I need to turn on. If I've used Z ordering, I'm using delta, then if I query using a search predicate that is one of my Z ordering columns, then it will automatically do data skipping. That's awesome. It's really, really good. So it's just now a more efficient query. And again, you can do things like ranges and all that kind of stuff. All works very nicely. You can do starts with, because it's this kind of dictionary-based minimum, maximum, things like range queries and that kind of stuff actually works really nicely if you've got a Z-ordered column. And again, we go in here, and it's only got those 5 columns. So that is the point of Z ordering. So you've got a few things where, if each individual file has to say what unique values have I got, and you're limiting the number of unique values in each file, obviously those files are processed quicker. So just generally queries around aggregates, around counts, around distincts, if you've Z-ordered those kind of queries are going to go faster. However, also, if you filter on it and you've Z-ordered on that column, you're going to get data skipping, and that is just a whole bunch of speed and optimization and great stuff. So Z-ordering really good. Now, you can Z-order by multiple columns. Now, obviously, because it has to organize the first one and then the second one, you get kind of diminishing returns on each additional column, and it does take longer. So the more complexity you add, the less likely you are to actually get it. Again, same as having a clustered index. If you try and cluster index by a whole bunch of columns, it's not that useful by the end of it. So have a bit of a think, and that's one of the big things when you've got a delta table and you're trying to think how you want to put that down on disk. Deciding do you want to Z order and what column you should Z order on is a fairly big thing. Now, it also depends on if you have that optimize step. So in here where I've written it, so I had to do that as a separate step. That's not me on write saying optimize this. And there is a Spark configuration called auto optimize. So you can auto optimize and auto compact. So you can say every time I write to a file, do a bit of optimization, do a bit of auto compaction, but you can't Z order those automatic ones. So if you want to have Z ordering, you need to do it as a deliberate separate task, but you don't need to do it constantly. You can run this as a weekend maintenance job. So all week long, you're going off running things, inserting data, appending, running merges, doing whatever. And then at the end of the week, say, right, just sort that table out. Again, keep hammering this analogy. It's like defragging an index, right? So it gets worse over time as these small files get created. And then you can step back and say, just go and order these, sort them out, make them more efficient. And that can be a nice asynchronous offline task. And again, because of the way Delta works, you can be optimizing a table, and someone can be querying it while you're optimizing it, and it's not going to use those new files until it's finished and it's actually created the new transaction log record. So it doesn't have to be an offline task. It doesn't have to be a weekend maintenance thing. And it depends when you want your cluster to be used, because that's the hard thing. Optimize is a heavy compute task. I think when I optimized this, it took 10 minutes, and it's not that big a table. Given I can query it in 3 seconds, in 2 seconds, actually reading that data is fast. But 10 minutes to bring it all back, sort it. It's doing sort operations, which are horrendously slow at the best of times. So optimize is not a fast thing to do, but it will make all your queries on it hopefully faster. As long as you Z order on the right column, as long as you pick the right thing to Z order by, then you're going to have a good time. Generally, you want to Z order by something that's got fairly high cardinality because it benefits from having this range, like this bucket of different values in there. If you pick something that's only got 1 or 2 values, you're not going to get that heavy data skipping. It's not going to be that important. So big performance thing, using Delta, use Z ordering, check it out. It is all of the awesome. All right, so that's all I want to talk about today. So have a look into Z ordering. Let me know what you think. Let me know if you've always seen it, never actually tried using it, and now you're going to try it out. Because hopefully you'll see some real performance benefits, and hopefully they should outweigh the time it takes to actually Z order your table. Again, bit of advice, if you're going to do it on a multi-terabyte table, plan out a long bit of time to actually go and do that. But then once you've done it, you can actually add in a Z ordering partition value. So optimize where add in a partition filter, Z order by. So a big task to Z order for the first time. And then as you go in, if you're updating just partitions, you can Z order and optimize each individual partition. So you're not having to do your whole table at once. So big job at first, and then just a regular maintenance routine, and it's really not so bad. Okay, so if you like the video, don't forget to like and subscribe. And we'll put another video that we made up there so you can go and check that out. All right, see you next time. Cheers.